This lesson is about area of a triangle and also applications involving area of a triangle. There are two formulas that we're going to use, and depending on how the information is presented, one is using an SAS formula, and so A, B, and C, and basically that area formula is found by taking the product of the two sides that form the angle, taking half of it and multiplying it by the side of the angle. And the other one is if you have all three sides, using something called Heron's formula, and which is located right here, and then with the semi-perimeter. So the first one that we're going to work is we're going to work with the area of the triangle with the angle. So that means we have to draw a picture because we need to know which way the triangle's presenting itself. So we'll call that A. I guess we'll put B down here and C over there. So B is 12 and C is 15. So this is SAS. And so your area, which is K, don't know why they use that, but they do, 12 times 15, and then sine 115, and you put that in your calculator, and you get approximately 81.6. So that is a pretty clear formula. It's pretty easy to use, user-friendly, not very difficult. Just make sure that you're using the correct numbers. And then this one, all three sides, so we're going to find a semi-perimeter first. We're going to add 13, 15, and 18 and divide that by 2. And so our semi-perimeter is going to be 23. And then we are going to apply the Heron formula. So the area is the square root of semi-perimeter 23 times, and now you're going to subtract each of the sides from 23. And you can put that in your calculator as is. If you want to simplify it a little bit, 23 times 10 times 8 and times 5, and then that is approximately 95.9. So there's a quick run through on how to use the formulas. Now we'll look at an application where we're going to find area and perimeter of a regular octagon inscribed in a circle. And instead of looking at the picture and complexity from geometry, let's do it like this. How many little triangles could fit in that octagon? That would be 8. These would be the radius, and the angle in here would be 45. And I got that because there's 360 degrees in the circle divided by 8. Then there'd be 45 degrees in each of the angles. And so we're also later going to need the missing side. So for area, we are going to do 1/2, and we're going to multiply 6 by 6 times the sine of 45. And that will give us the area of one triangle, but there's 8, so we got to multiply by 8, and we're going to get 101.8 square inches would be our label there. And then, battling my little box again. Now for perimeter, that missing side, that's an SSS triangle. So S squared is equal to 6 squared plus 6 squared minus 2 times 6 times 6. So not sine. Sometimes you guys do that. Be real careful. 6 cosine 45. Put that in your calculator, and you get that the side is 4.6. So then the perimeter is going to be 8 sides times 4.6, and that's going to give us approximately 36.8, and then that would be inches. So there's a little example there, hopefully that made it a little bit easier. So remember, the game that you have to play is find how you can do triangles and figure out how triangles fit into the situation. So this one, draw my parallelogram, and if I draw a diagonal, remember there's two congruent triangles. It says the included angle is 37, this is 14, this is 18. So then I would do 1/2 of the sides, 14 and 18, times the sine of the included angle, 37. Keep in mind that's the area of one triangle, and I'm going to double it because there's two, and that gets me 151.6. Okay, so now, so it gives you a couple basic formulas, a couple of applications. Now we're going to look at one where we're going to have to create triangles. So this trapezoidal lot, and we're going to have to do something from geometry, which is draw an auxiliary line, and then change this into 1 and into 2 areas. So the total area is going to be finding the area of region 1 and region 2. And one of the things we're going to do next is we're going to come up with how we can find it. So remember, these are parallel. So that angle measure there is a 70. And in a little while, I'm also going to utilize this side, so I'm going to put an X there. Okay, so now the first thing we're going to find is the area of region 1. And that area is 1/2. The sides are 45 and 55. And the sine of the included angle, which is 70. We put that in the calculator and we get 1162.9, and that's square feet. Okay, that's the area of 1. Now, the next thing we're going to do is we're going to work on the area of region 2. This one is going to require a little bit more work. So if you look at the triangle with the 45, 55, and the 70, that would be an SAS triangle. So I'm going to find X first. So 45 squared plus 55 squared minus 2 times 45 times 55 cosine 70. And putting that in and a square root, that gives me 57.9. And then my next goal is I see I have the sides of 25, and 60, and if I knew that angle in between there, that would be super helpful. So looking at it, I could set it up using the law of cosines in the alternate form. So I'm going to call that angle A. So cosine of A, two sides that make the angle, minus the side opposite the angle squared, over 2 times 25 times 60. And then the cosine of A equals 872.59 over 3,000. Take an inverse cosine, and my angle is approximately 73 degrees. So now I can find the area of region 2, which is 1/2, and then we're going to do 25 times 60, and the sine of the angle we just found, which is 73, and that's approximately 717.2 square feet. And so finally now we can find the total area, which is going to be taking region 1 plus region 2, so 1162.9 plus 717.2, and approximately 1880.1 square feet. So again, you have to, drawing the triangles, you could have drawn them the other way also, but I felt like this was probably the most efficient way to solve that. So the name of the game is try to figure out how triangles are involved in your picture and use the according formulas.